Hello, in this video I'm just going to go over a few examples on how to use the sum and difference identities. So your basic identities follow this pattern here. You have the sine of the sum of two angles x and y equaling here the sine of a single angle x times the cosine of a single angle y plus cosine of a single angle x and then times sine of a single angle y. So I'm reading it to you that way because you really do have to pay attention to how this is translating. And these are equal, so we can use them going this way or we can use them going that way. So what we're going to do in this video is use them going that way. So we're going to start with an expression that looks something like this and then transform it to something like this. Okay. Now I tend to memorize this in a more consolidated way because with sine you basically have sine of the first angle, cosine of the second, cosine of the first angle, sine of the second angle. And then if you start out with a plus, you end up with a plus. If you start out with a minus, you end up with a minus. With cosine, it's a little easier to remember this part. So you have cosine of the first, cosine of the second, and then sine of the first, sine of the second. But these get reversed. So if you start out with a plus, you'll end up with a minus. And if you start out with a minus, you'll end up with a plus. So that's why I put this in red here. If you have plus minus, it stays plus minus. But if you have plus minus, then it gets minus plus. Right? It gets switched up here. All right, so I tend to remember this because it's at least half as much to remember. All right, so let's say you're asked to find the exact value. Of course, that means you keep roots and constants like pi and things like that of the expression sine of 74 cosine of 16 plus cosine of 74 sine of 16. So when I look at my sum and difference identities, I first look for the form. This is all about form. What does it kind of look like? Well, I have sine, cosine, cosine, sine. So that's going to be one of the sine formulas. It's the sine of either the sum or the difference of two angles. And then since this is a plus, then that will also be a plus. So essentially what I'm going to have is I have this over here on this side, and I want to make it look like this. So this is going to be sine of 74 degrees plus 16 degrees. So I'm basically using this going this way, right? Where the 74 is here, the 16 is here, 74 is here, 16 is there, yeah, and 74 there, 16 there. All right, so we're going this way. Now all I have to do is just add these angles because I'm really told that it's the sine, that all of this is exactly the same as taking the sine of the sum of these two angles. So I'm just going to go ahead and add these two angles and I'll get 90 degrees. And then I'm taking the sine of 90 degrees, which we know, right? If you're here at 90 degrees, coordinates are 0, 1. The sine is the y coordinate, y over r. We can use the unit circle. So your answer is 1. Okay. All right, let's take a look at another example. Okay, again, we're using these formulas going this way. There are other videos where we use this going this way, but here we're going to go all the way, starting with these and going that way. So in this case, I have cosine, cosine, sine, sine. Now I'm working with one of these, right? Cosine, cosine, sine, sine. And since I have a plus sign here, then it must be a minus sign over there. So I know this is going to be the cosine of the difference of two angles, in this case of 204 and 69. Okay. So you go ahead and just subtract these. That's cosine of 135, right? And now we just evaluate cosine of 135 and say, okay, well, 135 here, right? Coordinates are negative square root 2 over 2 and then positive square root 2 over 2. And I want the cosine, which is the x coordinate, right? So that's going to be negative square root 2 over 2. Okay. Third example. All right, so go ahead and pause the video and try this one out. I'll go ahead and put the formulas up here for you, but go ahead and work that out. So hopefully you recognize that this is sine, cosine, cosine, sine, so it's one of these. It's one of the sine formulas. So, and since we have a minus sign right here, we're also going to have a minus sign here for the difference of two angles for the sine. So we're going to have sine of x minus y. So I'm going to put 298 minus 58. And so now I have sine, go ahead and subtract these, of 240. And then now we just evaluate that.
So 240 somewhere here, right? It's the equivalent 60-degree angle kind of thing. All right, so that's -1/2 and negative square root 3 over 2, right? Because you go over a little, down a bunch. So we're looking at the sine, which is the y-coordinate, so we want this one, negative square root 3 over 2. Okay. And our last example. So again, when you put the formulas here, you can pause the video. And hopefully you recognize this is cosine, cosine, sine, sine, so it's going to be one of these, right? It's the cosine of either the sum or difference of two angles. Since we have a plus sign, it becomes a minus. So I know my basic form will be like this, right? The cosine of the difference of two angles. And those two angles are 215 degrees and 35 degrees. So now I can actually just subtract the two and get cosine of 180. And now I just go ahead and evaluate it. And I say, well, here I am at 180 degrees. Coordinates are -1, 0. Cosine takes the x-coordinate over r. We can use the unit circle, so it's -1. Okay. Now, I will just mention that I think some of these are a bit contrived. So I know perhaps in a pinch, let's say if you were somehow you needed to evaluate something like sine of 75 degrees, you might be able to creatively realize that that's sine of 45 degrees plus 30 degrees, right? And then you say, well, okay, I can use my formula, right? The sine of the sum of two angles, and you'd say, well, the sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. And then you evaluate these, and you say, well, sine of 45 is square root 2 over 2. Cosine of 30 is square root 3 over 2. Cosine of 45 is square root 2 over 2. And sine of 30 is 1/2. Right? And then you do just the arithmetic, and you say, okay, well, here I have square root 3 times square root 2 is square root 6 all over 4. 2 times 2. And then here, square root 2 times 1 is square root 2, and then 2 times 2 is 4. They both have the same denominator, so you could say square root 6 plus square root 2 all over 4. And of course, you can't really simplify these, because if you look at the factorization of 6, it's 3 times 2, and you can't take anything out of the radical. So you just have to leave it like this. So this would be your answer. But I mean, really, this kind of thing would be really hard to imagine you needing. So my point is, I believe these problems, they're in a lot of textbooks. They're a little bit contrived, I think, basically just to have you get used to or gain a facility on how to use these. Because really what this is preparation for calculus when you have to do certain operations, and maybe you have this form, and that form is really hard to work with, but if you could get it into this form, it'd be a lot easier to work with, and that's really all they're trying to do is get you to get like familiarity with it. Okay? Thanks so much for listening.